Hello, everyone. Today, I would like to share with you how OTN transmits services in a unified manner. Unlike OTN, OTN achieves unified transmission of packet, SDH, and OTN services. In simple terms, an OTN device has packet, SDH, and OTN service planes. For any of these services, OTN uses a universal cross-connect board for unified cross-connection, and then uses a universal line board to encapsulate services into ODUK granularities for further transmission. How are the three types of services transmitted in a unified manner? First, let's see how the MPLS/PWE3 packet service is transmitted. The packet service board receives client-side services, and the universal line board outputs standard OTN signals. Now let's see the procedure for configuring packet services. First, packet services are transmitted over Ethernet ports, and the universal line board has Ethernet virtual ports on the packet service plane. Therefore, we need to bind the Ethernet virtual ports to ODUK channels on the line side. Create the mapping between the Ethernet virtual port and ODUK channel. Then, configure the Layer 3 attribute of the Ethernet virtual port, which is the NNI port attribute. In this way, a universal line board is logically an Ethernet board. Then, if packet services need to be transmitted on the packet cross-connect plane, the packet cross-connect plane must be capable of transmitting packet services, so the label switching function in MPLS must be available. Therefore, we need to configure basic MPLS parameters, such as the LSR ID and global label. An LSR ID identifies an NE on an MPLS network. Only an NE configured with an LSR ID can function as a transmission node on the MPLS network. The global label is configured to initialize the start label and label space on the MPLS network. After these basic MPLS parameters are configured, the packet cross-connect plane has the MPLS function enabled. Then, we need to create a pipe on the packet plane to carry MPLS packet services. This pipe is called an LSP or a tunnel on the MPLS network. To configure a complete tunnel, we need to select the source node, sink node, and intermediate forwarding node. The three nodes are also called the ingress node, egress node, and transit node respectively. After line-side services are configured, let's see how to configure client-side packet services. First, configure a port on the packet service board. The port is a UNI-port. Then, create a PW and encapsulate services into an MPLS/PWE3. The UNI port of the packet service board forwards the services to the NNI port of the universal line board. Then, the client-side packet services are transmitted to the line side through the packet cross-connect plane. In this manner, a complete signal mapping and forwarding process is formed. Now, let's make a summary. To configure an FPWE3 service, first, create the mapping from the Ethernet virtual port to the line-side ODUK channel. Then, configure basic MPLS parameters, including the LSR ID and global label. Finally, create a tunnel, configure a UniPort, and create a PW. You may wonder whether an MSOTN device supports the transmission of native services. The MSOTN device supports transmission of both native and PWE3 services. There are differences in transmitting native and PWE3 services. For native services, the MPLS function is not required, and no tunnel needs to be created. During PW creation, native Ethernet is created for native services. The PW carried packet service model is recommended for packet service transmission. Compared with a native service, a PWE3 service has 3 advantages. First, the PWE3 service has 2 layers of labels, tunnel and PW. The configuration of services with VLAN labels is more flexible. Second, the PWE3 service supports tunnel APS, PW APS protection, and fast switching, which can implement carrier-class transmission of Ethernet services. Third, the PWE3 service supports various OAM functions, such as MPLS TP-OAM, enhancing service maintenance capabilities. Now you should have a general understanding of transmitting PWE3 packet services. Please stay tuned for more MSOTN series videos. See you next time.